Here's another question of electrostatic, but this one is based on electric field. It says two positive point charges, which is Q1, it's positive 16 microcoulomb, and Q2, it's positive 4 microcoulomb, are separated by the distance. If you look here, this is positively charged, and this is positively charged as it mentioned there. Do you see? It's positive. They are separated by that distance, right? And there's a point P between the two charges, right? Point, there's no charge there, there's no electron, it's just a point, right? It's just this point. Now in a 9.1 it says draw an electric field pattern between the two charges. They're both positive. The electric field pattern, it's going to be something like that, guys, right? And this is 9.1. Because they're both positive, it's going to be like that, right? Okay, let's go to 9.2. It says define the term electric field. Guys, an electric field is a region of space in which the charge experiences a force. Is a region or a space in which the charge experiences a force, right? 9.3, it says calculate the distance d between the charges where the net electric field is 0. Guys, let's look here. They say here the net electric field at this point P due to Q2 and Q1 is 0. So the electric field that Q1 does on P plus the electric field Q2 does on P, when you add them, they are equal to 0. If you can see here, there are arrows. The electric field of Q1, it's going in that direction. The electric field of Q1 on P, it's going to the right. The electric field of Q2 to P is going to the left. So these are the direction of the electric field from Q2 and Q1. Now if you look at the distance from Q2 to P, it's D, right? But at the distance between Q2 and Q1, it's 3 meters. Now this question, it says if the net electric field here at P is 0, what is the distance D? What is this distance, right? So what is important, guys, here is to do the E net here. This is 9.3. 9.3. Let me use the red one. So guys, the net electric field of what? Of E1 plus E2 is equal to 0. But it's very important, guys, to understand E1 is going to the right and E2 is going to the left, which is negative. The one that is going to the right is going to be positive. So E2 is going to be what? Negative, right? And then the net electric field on P is 0. Therefore, E1 minus the positive times negative is going to be what? E2, right? So I'll transpose that to that side. So E2 is equal to E1, right? So this simply means that KQ of Q2 equal to KQ1 divided by R squared. So guys, if your net is equal to 0 all the time, the K's, you can cancel them. So you'll be left there with the Q2. What is Q2? Q2, it's positive 4. Positive 4 what? Microcoulomb divide by the E2, the distance here from here to here, it's what? It's D. So the distance there, it's going to be what? D. It's going to be D what? D square, right? And then Q1 is 16 microcoulomb. So it's 16 times 10 to the power negative 6 divide, and the distance between them, guys, if you're looking, this distance here between the two, it's going to be 3 minus d, and it's going to be that distance, right? So that distance, it's 3 minus d meter, this distance from there to there. So we substitute that, it's 3 minus d square. And then guys, in order for you to have an easy calculation here, you, instead of going to a quadratic equation and all that, you can just put a square root here. Square root here. So mathematically, it's going to be square root 4 times 10 to the power negative 6 divided by square root d square, square root 16 times 10 to the power negative 6, and then it's going to be a square root of 3 minus d square. Right? I hope that makes sense, guys, that type of calculation there. Right? So if you put square root this answer here, square root 4, it's going to be 2 times 10 to the power negative 3. Let me confirm that in my calculator. Where is my... Okay. Square root 4 times 10 to the power negative 6. It's going to be that. Yeah, I'm right. So divide by square root d squared, it's d. And then square root 16 is going to be 4 times 10 to the power negative 3. And that is going to be 3 minus d. And then that's the math after that. After that is the math. So it's going to be 4 times 10 when you cross multiply there, d, this times this, and then this times this. So it's going to be 6 times 10 to the power negative 3 minus 2 times 10 to the power negative 3 d, and then I take this to this side. So it's going to be 6 times 10 to the power negative 3 d equal to 6 times 10 to the power negative 3, and then we divide by this both sides, and then your d is equal to 1 meter. So this simply means that this distance now is what? It's 1 meter. No, it's not 1 meter. It's not 1 meter. I'm not correct. So it's going to be 3 minus 1, which is what? 2 meter. Right? And then, no guys, no, I'm wrong. This is the distance that is 1 meter. This one, d is equal to 1 meter, right? And then I was right here. This is going to be what? 2 meter, because you say 3 minus 1 is going to be 2, right? Let's answer quickly 9.4. Two spheres are allowed to touch and then return to their original position. Which spheres? Q2 and Q1, and calculated the number of electrons transferred from one sphere to another. Guys, you know what to do there. That's 9.4. So when they're allowed to touch one another, there will be new charge between them. It's Q1 plus Q2 divided by 2. So it's 16 times 10 to the power negative 6 plus 4 times 10 to the power negative 6. And then we divide by 2. And the new charge there, it will be 10 times 10 to the power. When you punch that in the calculator, minus 6 coulomb. And then we'll calculate the charge transfer. It's going to be Q new minus Q original, which is the Q new. It's 10 times 10 to the power negative 6 minus the original. The original, we can take 16. We can take 16, so it's going to be negative. Negative. The answer here, it's going to be 10. It's going to be negative 6 times 10 to the power negative 6, right? And then coulombs, and then we go to the number of electrons. It's Q divided by the elementary charge. So it's going to be 6 times 10 to the power negative 6 divided by negative 1.6 times 10 to the power negative 19. Okay, let me punch that in the calculator. So it's 6 times 10 to the power negative 6 divide by 1.6 times 10 to the power negative 19. It's 3,75 times 10 to the power 13 electrons, right? These are the electrons that were transferred when Q1 and Q2 touched and then separated. Hope you understand. Cheers, bye.